right, here we go. We're still talking about 4.3. Stay with me. We're talking about 4.3. We're on page 204. We've talked about a conditional statement. We talked about if-then. We talked about converse, inverse, and contrapositive. The next statement, line 6 here, we skip negation now. Those of you watching at home, we didn't talk about negation. I skipped over that. Line number 6 says equivalent statements. Okay, it says when two statements are both true or both false, they are called equivalent statements. Well, that's kind of common sense. I'm not going to spend a whole lot of time on that. Line 7 says, if two lines intersect, this is going to be our second example. If two lines intersect, write this down in your notes, to form a right angle. Okay? What is that? Is that the hypothesis or the conclusion? That's the hypothesis. We've got two lines. They intersect to form a right angle. Okay? Then, our conclusion is what? They are perpendicular. Write that in your notes if you haven't already. Okay, so this is a geometry definition that we're going to get to use our converse, inverse, and contrapositive. So this is our second example. Okay, questions? Colin, you good?
Yeah.
Okay. So if two lines intersect to form a right angle, then they are perpendicular. That's the symbol for perpendicular. It's an upside down T. Okay, so if this, then this. We can say they are perpendicular. All right, so now let's practice. All right. What would the converse of this statement be? Boyd? You have to describe it in the hypothesis. I'll give you a hint. You have to describe it in the first part. I'm going to do some abbreviation, but you'll get the idea. You want me to get you started?
Would it be there perpendicular if two lines intersect?
That's good, except for I want you to put the two lines in the beginning. Describe it in the hypothesis. Right? And we always want to start out with if. If we're doing if-then statements, we're going to start off with if. First word's going to be if every single time. If two lines, right? So I'm going to abbreviate a little bit. If two lines are what?
Perpendicular.
Are perpendicular, right? Then what has to be true?
They intersect to form a right angle.
They intersect to form a right angle. Exactly right. Write that down. All right. Are you with me? Yes. As you do more and more examples, you'll get better at this, right? We had to describe it in the hypothesis. That goes ahead and lets the reader know what we're talking about, right? If I put the two lines in the conclusion, right, then he has to kind of guess what we're talking about. But if I say if two lines are perpendicular, then they intersect to form a right angle. I should have put they. Intersect to form a right angle. Okay? All right, now let's talk about the inverse. And let me say this again. Order doesn't matter here. I could ask you what the inverse is and then ask you the converse. Or I could ask you the contrapositive right off the bat. Okay? There's no real order to these. Okay? James, what do you think the inverse of our original statement? I will say this. A common mistake is to do the inverse of the converse. What is the inverse of the converse?
Contrapositive.
The contrapositive. So we don't want to do that yet. The inverse, we go back to the original statement. And we add in a what? Not. That's an easy way to remember it. Put that on your note cards. All right, so James, what would the inverse of our original statement be?
If two lines intersected to form a right angle.
Careful. Inverse, we add a not. I didn't hear you say a not, did you?
No, I didn't.
Okay, if two lines do
No.
not intersect, hold on, let me catch up. All right, I'm caught up. If two lines do not being the important word, intersect to form a right angle, then they are not perpendicular. Outstanding. Okay? Exactly right. Questions? All right, last one is contrapositive. Let's finish it up. What would the contrapositive be in this case? Anybody, raise your hand if you can do the contrapositive. Chester?
Hold on.
I'll give you a second because it takes a second to think about it.
Wait a minute. If two lines do not, wait a minute.
Sometimes you have to think about the tense, right? There's a lot of English involved. And I'm not going to be that nitpicking. Think about it. If two lines
Do not intersect.
are not perpendicular,
then they do not intersect to form a right angle.
perfect.
Could you put will?
All right, hold on. I'll answer your question in just a second. Then they do not intersect to form a right angle. All right, what was your question?
Could you put will not intersect to form a right angle?
If two lines are not perpendicular, then they will not intersect to form a right angle. Yeah, you could. That would be fine. Okay, good question. Anybody else have a question? Any questions? So here we have another example of an if-then statement. We wrote the converse, the inverse, and the contrapositive. Okay, we only got one more topic to talk about. It's a big one, but we only got one more thing to talk about. Everybody good? Can I erase this? Everybody got this written down? All right, I'll give you a second to write it down. Let's talk about this next statement while you're finishing writing that down. All right. When a statement and its converse are true, this is the last line on page 204 in the box. When a statement and its converse are true, you can write them as a single biconditional statement. Right? This is a conditional statement. If we start talking about a biconditional statement, then the statement and its converse, meaning when we swap it, both of them have to be true. A biconditional statement is a statement that contains the phrase if and only if. Do we have an abbreviation for if and only if? Anybody know? Oh, you're going to learn something. What is the abbreviation for if and only if? Very good. IFF. Write that down. IFF. If and only if. We only use that with a biconditional statement. In your notes, right there on biconditional, write do not start with if. No biconditional statement starts with if. Okay? The if part is in the middle, right? Because we say something is true if and only if something else is true. Okay? That's what we're going to do an example. That's what a biconditional statement. Can I erase now? Okay. So here we go. Let's talk about our first example over there. If it is raining, then I will stay inside. And this is not necessarily going to be a true statement. But if it is raining, then I will stay inside. How could we rewrite that as a biconditional statement? Remember, don't start with if. We don't ever start with if. What would it be, Mathis?
It only rains if and only if rain falls from the sky.
You're on the right track. But stick with our... Don't change. You changed it up a little bit. Hypothesis and conclusion. It is raining, what? If and only if, what? I stay inside. Now, is that true or false? False, right? It could be nighttime and you be inside. It doesn't necessarily have to be raining. So that statement there as an if and only if statement is not true. Okay? But we can write it as a biconditional statement. Notice, hey, if I'm checking these and I see you started off with if, immediately I mark it wrong. No biconditional statement starts off with if. Okay, that I'm aware of. The if and only if is always in the middle. It is raining if and only if I stay inside. So we said that that was not a valid statement. All right, let's do one that is valid. Let's do the one that we did just a minute ago. If two lines intersect to form a right angle, then they are perpendicular lines. Can we rewrite that as a biconditional statement?
Yes.
All right, what would it be?
Two lines intersect to form a right angle if and only if they are perpendicular.
Outstanding. Exactly right. It's hard because I'm listening and trying to write at the same time. Two lines intersect to form, write this down, guys, a right angle if and only if they are perpendicular. And guys, that makes sense. If I draw two lines and they intersect to form a right angle, they're perpendicular. The vice versa is true. If two lines are perpendicular, then they intersect to form a right angle. It's true forwards and it's true backwards. Okay? Both the converse and the regular statement are true. We can swap it around, and either way, it's true. Now, what does our last line on our definition over here say? Any valid definition can be rewritten as a what? As a biconditional statement. So was that a valid definition? If it's raining, then I will stay inside? No, that one wasn't valid. Was this a valid definition? Two lines intersect to form a right angle if and only if they are perpendicular? Do you see the difference? Okay, good. So when you make your statement to your mom about going to the party, do you want it to be over there a biconditional statement, or do you want it, or a conditional statement, or do you want it to be a biconditional statement? A biconditional statement, because that's going to be true forwards and backwards. What is your mom looking forward to be able to not allow you to go to the party? No, we learned it the other day. Just one. All she has to do is come up with one. A counterexample, right? You say, but Mom, everybody's going to the party on Friday night, right? And she picks up the phone and calls your friend's mom and she says, no, I'm not allowing her to go. So there's a counterexample, and then she says, nope, sorry, you can't go. Right? I know this never happened. Y'all never have this conversation with your parents? That never happens? Huh? Your mom just says no right off the bat?